Hi everyone, today we'll do some good questions based on the topic of friction. But before we solve the questions, let us quickly revise the important concepts and formulae in friction. Imagine this is some block on a flat surface and you apply a small force. This is applied force. So in your house, you imagine there is a table and with your pinky finger you push the table. Will the table move? No, right? Why it is not moving? Because Newton's second law says if you apply force, the body should accelerate, its velocity should increase from rest, isn't it? Then why it is not moving? Well, the only way after applying force also, if the block is not moving, that is only possible if there is another force in opposite direction, and that force should exactly balance this applied force, isn't it? From where this force will come? Well, who is in contact with this block? Search. The only thing in contact with this block is the floor. So this force is coming from floor. So this is by floor. Is it the normal force? No, normal force acts perpendicular to surface. We have seen in our previous video, right? So which force is this? This is what is called friction. And since it is trying to keep the body at rest by cancelling the applied force, this friction is called static friction. So if the body is not moving even when we apply a force, it means static friction is balancing the applied force. Meaning static friction is equal in magnitude to applied force but opposite in direction. Okay? However, you all know that if you keep increasing your force, then static friction will also try to increase. To keep the body at rest, static friction will also try to increase. But you all know, if you apply too much force on the table with both your hands, or call your father also and push the table, then the table will move. That means, though static friction tries to balance the applied force, static friction has a maximum value. And beyond that, if you apply force, static friction will not be able to balance the applied force. So remember, static friction has a maximum value. So if your applied force is more than this maximum value, then the body will not be at rest with respect to this surface. And the formula for maximum static friction is mu s into the normal force. Okay? This mu s is called coefficient of static friction. Coefficient of static friction. Now, once the body is moving on the surface, then the friction which comes into picture is called kinetic friction. And the formula for kinetic friction is mu k into L. And this is called coefficient of kinetic friction. So these are the main three formulas in friction. Generally, the coefficient of kinetic friction is less than coefficient of static friction. Try to remember it. However, in some questions, they will say coefficient of friction between the surfaces in contact is mu. So if they just give you the coefficient of friction, then you can assume it is equal to mu k also and mu s also. Okay. Now, those three formulas, if you combine with Newton's laws, you can solve many problems of friction. However, if you remember some other formulas, it will be useful for you to solve the problem faster. So let me give you some formulas where friction comes and the body is moving on an inclined plane. So suppose you discuss the first case where your inclined plane is smooth and the angle of inclination is theta, and here is your block which is left free. Now what forces will act? Well, here one component of mg, remember, is acting here, right? And the component of mg here is mg cos theta, and this component is mg sin theta. And there is a normal force which acts perpendicular to the surfaces in contact. So this is the surfaces in contact, so normal will act perpendicular to their surface. And since the surface is smooth, it means the coefficient of friction is 0. So there is no friction in this problem. Then you can see in this direction there is no acceleration, right? So normal will balance mg cos theta. and this side the only force is mg sin theta. So apply Newton's law in this direction. So let us say it has acceleration a in this direction, and write Newton's law in this direction. Net force equal to ma along the plane. Remember, whenever you write Newton's law, you are writing it in a particular direction. So along this direction, what is the net force? This is along plane. So in this direction, the only force is mg sin theta, right? M into a. So m gets cancelled. So try to remember, when a body slides on a smooth inclined plane, its acceleration is g sin theta, and it is down the plane. Down the plane. Now let us imagine our body is on an inclined plane, and here there is some friction. So mu is now not 0. So there is some friction. Now what will happen? Now first you have to check whether the body will fall or not fall, because friction is there. So static friction will try to keep the body at rest, right? So here, which force is trying to pull it down? Mg sin theta, isn't it? And here friction will try to balance it. Right? Now, as long as your applied force in this direction, in this case the applied force is not by you, it is by gravity, right? Component of gravity. So if this force is less than the maximum static friction, then the body will be at rest. Once your mg sin theta will become more than this, then the body will slide. Now, when will be mg sin theta more? When you increase theta, isn't it? Sin theta increases with theta, we all know. Sin 0 degree is 0, sin 90 degree is 1. So as theta increases from 0 to 90 degree, sin theta value increases. And when this becomes greater than maximum static friction, the body will slide. So for body to be at rest on the surface, what should happen? Mg sin theta should be less than or equal to maximum static friction. Right? It should not cross this friction. That means mg sin theta should be less than equal to mu s into n. And here n is balancing which force? N is balancing mg cos theta, right? So mu s into n, and n is mg cos theta. Mg gets cancelled. So if you bring cos theta, your tan theta should be less than equal to mu s. So as long as your tan theta is less than equal to mu s, the body will still be at rest. Now what will happen if tan theta is greater than mu s? Then the body will slide on the surface. Okay? And that angle where it is about to move, how will you find that angle? Very simple. Just make tan theta equal to mu s. Because less than mu s, it will not move. Equal to mu s means what? It is about to move. Okay? It is about to move. So at that angle, this formula will be tan theta equal to mu s, and theta will be tan inverse mu s. And this angle is also called in physics angle of repose. Okay, so if your angle is greater than this, it will move. If your angle is less than this, the body will stay at rest. Now let us assume the angle is greater than angle of repose. Then the body will slide. When it will slide, let us see what will be its acceleration. So if this theta is greater than theta r, where theta r I am using for angle of repose. This is your angle of repose. Okay. Then the body will slide, and once it slides this way, its acceleration I want to know. Well, now which force is bringing it down here? Mg sin theta, right? And which force is opposing this force here? Kinetic friction, isn't it? Now friction will be kinetic. So apply Newton's law in this direction. Net force equal to ma. What is the force in this direction? Mg sin theta minus friction, because it is opposing this force, right? That is equal to m into a. This is mg sin theta. Friction is mu k into n, and n will balance mg cos theta. So in place of n, I can write mg cos theta equal to m. You can take m common and then cancel. So acceleration when there is friction and the body is coming down the plane, remember, I'm not saying body is going up the plane but down the plane. Then acceleration is g sin theta minus mu k g cos theta. So this is the acceleration when a body slides down on a rough inclined plane. So let us solve the first question. Here is a block on a flat surface, horizontal surface, remember, and this F is the applied force. And this applied force, what it does, they have written, it just makes the body move. The most important word here is just. So you know that there is a static friction which will try to balance this force, right? Now as you increase your force, static friction will also increase. It will try to keep the body at rest. When static friction reaches maximum value, up to that point the body will still be at rest. So imagine your maximum value of static friction is 10 Newton. What does it mean? It means static friction can go up to 10 Newton. This doesn't mean static friction acting right now is 10 Newton. No. It means up to 10 Newton it can increase. So suppose you apply 8 Newton. So what will be static friction? Well, it will try to balance the applied force. Since static friction can go up to 10, easily it can reach 8 Newton, right? So if you apply 8 Newton, will the body move or will it be at rest? Well, since 8 Newton is less than maximum static friction, the body will be at rest. And that time what will be static friction? 8 Newton, because static friction is always equal to applied force, right? Now, but they told this force just moves the body, meaning as you increase this force 9 Newton, 10 Newton. Now when this force becomes 10 Newton, still it is at rest only because static friction can reach up to 10. But the moment you apply applied force 10.000000 up to Mysore you put 0, then 1 Newton. Then the body will move because this force is greater than this force, right? But they told just moves. That means your force applied is very close to 10 Newton but slightly more, which means for calculation purpose I can assume the applied force is 10 Newton only. Yes or no? Who will worry about the 0.00001, isn't it? So at 10 Newton I can assume the body just begins to move, meaning that time your applied force is same as maximum static friction. Okay, so what does this word just here means? It means this force is just equal to maximum static friction. Now they told if the same force continues to act, then what will be its acceleration? So once it has acceleration, now the friction that will come will be kinetic friction. So now apply Newton's law in this direction. Net force equal to ma. Applied force minus kinetic friction equal to ma, isn't it? Applied force is this side, kinetic friction is this side. Now because of this just word, in place of applied force we can write maximum static friction. Clear? Now write formula. What is maximum static friction? Mu s into n, this is mu k into n equal to ma. Then here you can take n common, mu s into mu k. And n is balancing what here? Because the floor is horizontal, n will balance mg equal to ma. M gets cancelled. So the acceleration of the body is mu s minus mu k times g. Here mu s is given 0.4 minus 0.2. G we will take 10. So 2 meter per second square. Right? Let's do the second question. It's quite interesting. Here is a block which is sliding on a rough inclined plane of inclination 45 degree. The time taken to reach the bottom is t1, and same inclined plane when it is smooth, the body takes time t2 to cover the same distance. Inclination is 45 degree because same incline. Now they have mentioned here the time taken is n times more than here. Obviously because this is rough, so here it will come more slowly, right? Acceleration will be less here. So they are asking you if the time taken here is n times more, what will be the coefficient of kinetic friction here? Because this is rough. In terms of n we have to find. So here we need to try to remember the formula for acceleration when the surface is smooth inclined plane. So if you remember, acceleration was g sin theta, right? And therefore how can we relate time taken here with this displacement? Well, displacement here is s acceleration here we know, so we can write kinematic equation. S equal to u is 0, so half a t square. Time taken here is t2, so let me call this acceleration a2. Remember, displacement is same because it is falling in the same plane from top to bottom, so displacement will be same. For rough plane, acceleration, if you remember, here let me call the acceleration a1. Okay, if you remember, it was g sin theta minus mu k g cos theta. Okay, check the notes of that. And displacement will be half, acceleration is a1, time taken is t1 in the rough plane. So now both are the same displacement on the left hand side, so we can equate the right hand side. The half will cancel, so a2 t2 square, which is for the smooth plane, is equal to a1 t1 square. So a2 t2 square will be a1. Now time taken in the rough plane was given n times time taken in the smooth plane, right? It was given t1 is equal to n times t2. So substitute here. So t2 square will cancel, so a2 will be a1 n square. So t2 square here will cancel, n square will be left. Now what is a2? Remember, g sin theta, and a1 is in the rough plane, g sin theta minus mu k g cos theta, that is your n square. So from here g you can take common and cancel. Now remember, we want to find mu k. Okay, so we need to bring this mu k on the left hand side. So here sin theta is equal to, sin theta into n square will be sin theta into n square minus mu k cos theta into n square, right? Now you bring this whole thing here, so mu k cos theta n square will be, take the sin theta here, from here and here sin theta you take common, so n square minus 1. So finally your mu k will be equal to sin theta n square minus 1 by cos theta n square. So your mu k will be equal to tan theta into n square minus 1 by n square. And since theta was given 45 degree, tan 45 degree is 1. You should know, so this whole tan theta will be 1. N square by n square is 1, 1 minus 1 by n square. So either you can write this way or you can write this way depending on the option, right? Let us see the third question. So here is an inclined rough plane. How I know it's rough? Because the coefficient of friction is given 1 by root 3. And the body is projected with initial velocity 20 meter per second from the bottom. We have to find the time taken by block to come to stop. So as it moves up, how much time it takes to stop. But be careful this time. Don't use directly the formula for acceleration in rough inclined plane. Why? Because there I assume the body is coming down. If body is coming down, friction will be up the plane. But here body is going up the plane, so friction acting, kinetic friction acting will be down. So what are the forces? Here you know mg sin theta will be down only. Down means down the plane, and because it is going up, friction will be also down, kinetic friction. So this time both the forces are acting in opposite direction to initial velocity. So net force equals to ma. You can see both the forces are in same direction. So we should add mg sin theta plus kinetic friction, that is equal to ma. Now before, here there was minus sign because that time I assume body is coming down, so friction will be up. So friction will oppose mg sin theta, so minus sign. Here both are helping each other, right? So both are helping each other, but both are opposing the motion. Remember, motion is up the plane, no? Now what is the formula for kinetic friction? Mu k into n, and n here will balance mg cos theta. We know that, okay? So directly I will substitute, equal to ma. So you can see m is common everywhere. So your acceleration is g sin theta plus mu k g cos theta. So if I take g common, sin theta plus mu k cos theta. Well, g I will take 10, sin theta is 30 degrees, so 1 by 2. Friction coefficient 1 by root 3, theta is 30 degree, cos 30 degrees root 3 by 2. Root 3 cancel, half plus half will be 1, so 10 meter per second square. Remember, but it is down the plane. Initial velocity is up, remember. That is why it will come to stop, because it will retard. So these forces are creating retardation to this body, remember. Now wherever it stops, let's say here, its final velocity will come to 0. So let us use the formula v equal to u plus at, because a is constant, right? So v is 0, initial is 20. Acceleration, while substituting, you have to put minus 10. Because initial velocity is here. So if I take plus here, this should be taken minus, right? So time taken will be equal to 2 seconds. Let's try this question. Two blocks A and B are attached to each other through this string. And please, in such questions, assume the string pulley are ideal. So tension everywhere will be same. Mass here is Ma, mass here is Mb, and here there is a coefficient of static friction mu s. So what we have to find is, find the maximum mass of B so that this A remains at rest. Now why they are asking like this? Think. If you keep increasing the mass of this, the pull here will increase. That will increase the tension here. And if tension here keeps increasing and it becomes more than maximum static friction, then the system will move. So they don't want the system to move. So they want the mass to be less, the mass here should be less than some maximum value. That maximum value they are asking. Okay. So let's apply the free body diagram. Here tension is T, weight is Mb into G, and here same tension will act T, and here one static friction, Fs, right? Now for system to be at rest, remember, if this is at rest, this also should be at rest, right? Otherwise the string will break. So for system to be at rest, who will balance the weight of Mbg? Tension, right? So this is for this block. And who will balance tension here for this block? Tension here will be balanced by static friction. That means I can substitute this tension here. So static friction in a way should balance Mbg, right? Now we know that static friction should be less than equal to maximum static friction, because this is the maximum static friction. Static friction cannot go beyond this maximum value. So static friction should be less than equal to maximum static friction. What is static friction here? Mbg, to keep the body at rest. Less than equal to, formula for this is mu s into normal. Normal here is balancing whose weight? Mag. So normal here is balancing Mag, remember. So formula for maximum static friction is mu s into n. N here is balanced by Mag. G can be cancelled. So whatever is the mass of B here should be less than equal to this. That means the maximum mass that you can keep here, should be equal to mu s into Ma. Right, students? So that is the answer for maximum mass of B, mu s into Ma. Right? Because Mb should be less than equal to this value, right? If x is less than equal to 10, that means maximum value of x is how much? 10 only. Because other values are less than 10. So this is the answer for this question. So this question, you see, it is similar to the previous one, where this is the mass top, meaning mass on top of the table, and this is M hang, which means mass which is hanging from this thread. And here the coefficient of static friction is mu s. Now the question is, if this system is about to move, which I did in the previous example, I asked what is the maximum mass of this, so that the system is still at rest. Now what happens if you do it slightly more than maximum? It will begin to move, right? So if the system is about to move, which means mass here has reached its max value, okay, then what was the connection between these three masses I told? Mass of this, the maximum mass of this is equal to mu s into mass on top. So try to remember this formula many problems you can do it faster. Okay, mass hanging is equal to mu s into mass on top, or you can remember this way: mu s equals to mass hanging divided by mass on top of this table. Now when this is used at critical point. Critical point means what? When friction has reached max value, which means it is still just at rest but it is about to move. Okay. Now see this question. Here there is a 10 kg block, here 5 kg block, here coefficient of static friction is 0.2. Okay. Now they are asking you what should be the minimum mass of this block C, so that the system remains at rest. Now here what we have to calculate? We have to find the minimum mass of block C to prevent this system from moving. Now before we calculated maximum mass of this. Now why they are saying minimum mass of this? Think carefully. The more is the mass of this, the easier it will find to move. And here the lesser mass it has, easily it will move, because if here less mass is there, then static friction will be less, because normal force here has to balance mg, right? So if the mass here is less, normal will be less, static friction maximum value will be less, so tension will find it easier to move. So if you want the system not to move, this mass should not be more than certain value and this mass should not be less than certain value. Simple, right? So this should have a minimum mass, not less than that. Otherwise the system will move. Now you don't have to repeat everything, because once they say minimum mass of this or maximum mass of this, they are talking about the critical point where static friction has reached max value. So we can directly remember the formula. Coefficient of static friction is equal to mass which is hanging by mass which is on top, right? Now this is 0.2, mass hanging is 5 kg, mass on top is 10 kg plus unknown mass, which I will write mc. Cross multiply, 10 plus mc will be 5 by 0.2. So 10 plus mc will be, this is 50 by 2, 25, right? 50 by 2, 25. So mc will be 15 kg. So that is the minimum mass. Okay, if you put less than this, the system will move. Okay, so let's do the next question. Here is a uniform chain. By uniform they mean the mass is uniformly distributed. So every centimeter will have same mass. Now the coefficient of static friction between the chain and the table here is 0.5. They are asking what maximum percentage of length can hang from the table so that the chain does not fall. Now you know that if you keep increasing this part of the chain, then it will slip at one moment, right? So they are asking how much maximum can be kept here. Maximum length in percentage they are asking. So how do we solve this? Now here we can directly use the previous concept. Why? Is because they are asking here maximum length. And when the length here is maximum, the mass hanging will be also maximum. So coefficient of static friction, what was the shortcut formula? Mass hanging divided by mass on top, right? This is provided the system is about to fall, remember. That happens when this mass is maximum or this mass is, remember, minimum. So they can also ask the minimum length which should be on the table. Okay. Now, what is the mass hanging? How to find? Since they told the mass is uniformly distributed, that is the meaning of uniform chain, we can easily find the mass of hanging by using this concept. Let me say m is the mass of the chain, the total mass. The total mass. And capital L is the length of the chain. So if capital M and capital L is the total mass and total length, then M divided by L will be what? Mass per unit length. This is similar to cost of 10 apples divided by 10 apples. That will give you cost per unit apple. Then if you multiply with 6 apples, you will get cost of 6 apples. So this is mass per unit length of the chain. Now I want mass which is hanging. So let's say this length is L1, which is hanging from the table, or let me write L. Then what will be mass hanging? Total mass by total length is the mass per unit length into this small l, which is the length which is hanging. That will give you mass of the hanging portion. Similarly, what will be this length? Well, if total length is capital L, this will be capital L minus small l, right? So the mass on the top of the table will be total mass by total length into length which is on the table, on top of the table. How much length is on top of the table? Total length minus this length. So I hope this idea is clear. Okay, so this is how I converted mass into length. So this gets cancelled. Now here mu s was given 0.5, or let me write in terms of mu s right now. So L by capital L minus L. So let's simplify this now. First you cross multiply mu s into capital L minus mu s into small l equal to small l. Remember, our aim is to find the length which is hanging in terms of percentage. Take this one this side. So mu s l plus l. So if I take l common, mu s plus 1 into l, right? So l will be mu s by mu s plus 1 times l. So this much maximum length can hang from the table if you don't want the chain to fall. Now here mu s was given 0.5, which I can write 1 by 2. So 1 by 2 plus 1 by 2 will be 3 by 2. So how much length can be there? 1/3. So if they ask fraction, how much fraction can be? 2 will cancel, right? So how much fraction can hang from the table? If they ask, the answer is 1/3 of the length. So answer is 1/3 if they ask fraction. But percentage they asked. Now 1/3 can be written as 0.333. Right? 1 by 3 is 0.33333. So this will be 33.3%, isn't it? 33.3% means 33.3 divided by 100, which is this only. So this is the answer for this question, because they asked in terms of percentage. But if they ask in terms of fraction, then the answer is 1/3. Okay. Okay, here is another interesting question. Here is a hollow cylinder. This is a hollow cylinder, and there is a man on the inner surface of the cylinder. Now the man is in contact with the inner surface. Now you know that here gravity is down, so the man will fall down, right? However, if you spin this cylinder, then the man will press the cylinder, right? So as he presses the cylinder, there will be a normal force. So there will be a friction force which will oppose the tendency of falling of the man. So the man wants to slip down, so friction will oppose that. So this will be your friction. So they are asking what should be the minimum angular speed. Omega here is angular speed. So what is the minimum angular speed you can give to this cylinder so that the man does not fall? So practically, if you take a hollow cylinder, okay, and there you put a marble on the inner surface. If you leave it, the marble will obviously fall. But if you rotate the cylinder, then the marble will keep rotating without falling down. So something like that here we should do. We should rotate this very fast so that the man will press the surface, which creates in normal force, and therefore there will be a static friction which will oppose the mg, right? So now for man not to fall, who should balance mg here? Remember, the force parallel to surface is friction and the force perpendicular to surface is normal. Okay now? So here static friction should balance your weight. There's no other way. What about this normal force? Remember, the man is going in a circle, and whenever you go in a circle uniformly, you need a centripetal acceleration towards the center. So don't think this normal is balanced by any force. Here normal is needed to provide this acceleration according to Newton's second law. Thus, force towards the center, which is in this case normal, should provide ma, and a, remember, is centripetal. What is the formula for centripetal acceleration? V square by R. But here they want in terms of angular speed. And the man is moving in a circle of radius same as radius of the cylinder. This R is the radius of the cylinder. So when a person is going in a circle of radius R with linear velocity V and angular velocity omega, I gave a relation between these two. What was the relation? V equal to R omega. So in terms of R omega, this radius here is capital R. So V can be written as R omega square by R, which is m into R into omega square. In fact, this is another formula for centripetal acceleration which you should know. There are two formulas, right? One is V square by R, other one is R omega square. Now, this friction we know is less than equal to maximum static friction. Here the friction should balance mg, so this friction should balance mg. And maximum static friction is mu s into n, and n here is m into R omega square. So n gets cancelled. So from here if I divide by mu s r, I will get g by mu s r should be less than equal to omega square, which basically means omega square should be greater equal to g by mu s r. So omega should be what? Greater or equal to square root of g divided by mu s r. Now if something is greater or equal to 10, what is 10? The minimum value. This 10 is the minimum value of x. So this is the minimum value of omega, root over g by mu s r. So as long as the body rotates with omega which is more than this, then the man will not fall. But the moment omega becomes less than the minimum, then it will fall. Okay. Now I would like to discuss few problems based on block problem. Okay. So imagine block B is on top of block A, which is on some table or some surface, fixed surface. Now, suppose you move this block this side, you apply some force. Now where will friction act? The best way to find the direction of friction is this. Assume there is no friction and see which way the surface will move. Opposite to that, friction will act on that surface. For example, on an inclined plane, imagine there is a book. How to find direction of friction? Assume there was no friction, then what will happen? This block will fall down, so friction on the block will be opposite to that. For example, if there was no friction here, this body will go this side, so friction on this will be this side. Similarly, if there was no friction here also, this body would go that way, so friction here would be this way. F dash, let me write. So this is friction on A by B. This is friction on A by floor. Now reaction of that friction will act on B this side, remember. So this F dash is what? Friction on B by A. And this is on A by B. Remember, for every action there should be a reaction. In fact, here also there will be force on the floor, friction on the floor by the block A in opposite direction to this. Okay. Now you must have seen like this, right? This is the tablecloth, let's say. On top of the tablecloth you put a mobile. So when you apply force on the tablecloth, you will see sometimes mobile will also come. Now who is accelerating the mobile? The answer is friction on the mobile by the tablecloth, because it is in this direction. Okay. What if you apply force on the upper block B? Then what will happen? Well, think if there was no friction here, what will happen? If there was no friction here, B would go that side. So friction on B will be here. Reaction of that friction on A will be here. And if there was no friction here, because of this friction, this body would go here. Right? So friction on this will be here. So this is friction on A by the floor. Okay. So let's do this question. Here is two blocks, masses M1, M2. Here there is friction, meaning this surface is rough here and the friction coefficient is given mu, and here I am assuming there is no friction. We are applying a force F here, and the question is to find maximum value of this applied force so that both move together. So you know that if you keep increasing this force too much, then they will be slipping. Then this block will not move with this block together, right? So we have to find the maximum force F that can be applied to this block so that both of them move together. So how do we solve this? First, assume both the blocks are moving together. So assume both blocks move together. Now for both the blocks to move together, their acceleration should be same. So take m1 plus m2 together as system. So this I am taking as a system. And they should have common acceleration if they move together. Let us say the common acceleration is A. Now, whatever friction acts between these two, that will be internal force. And internal force we don't include while writing Newton's second law. So for this system, if I write Newton's second law, then net force on the system is mass of the system into A. The only force on this system along x-axis is F. Right? There is no friction here, remember. It is smooth. Okay. And mass of the system is m1 plus m2 into A. So this is what is your A. So A will be what? F by m1 plus m2. Now, take m1 as system. Only m1 as system. Only m1. Now, who is giving m1 this acceleration? Is it this force? No, this force is acting on m2, remember, not on m1. So who is in contact with m1? M2. And this surface is rough, they told. So there will be friction on m1 this side. And that must be static because remember I am assuming they are moving together. So with respect to one surface, the other surface is at rest because they are moving together. So this static friction has to provide acceleration to this block m1 into A, same acceleration. By the way, why I showed friction here? I hope you understood, right? When you move this block here, this block would move this way. So friction on this block will be here. Reaction of that will act on this m1 here. Right? Okay. Now, we all know static friction has a max value. And that max value, when it reaches, your A will also reach max value. And what is the formula for maximum static friction? Mu s into n here. And n here has to balance only m1g, isn't it? So m1g equal to m1 A max. M1 cancel. So A max is how much? Mu s times g. So remember, this is the maximum acceleration static friction can give. Now, when this A is maximum, the force required here will be also maximum, right? So when this A is maximum, this force here will be also maximum. So if you cross multiply, what is the maximum value of this force? Remember they asked. So F max will be m1 plus m2 A max. And what is A max? We calculated. A max is mu s g, right? So this is the answer. So here is the similar question, only difference is here we have assumed the surface is rough now and we want maximum F so that both blocks move together. Both blocks move together. So already we did for M1, if you take a system, the only force going to accelerate it this side is your friction force. And we calculate A max to be equal to mu s g. So this part already we found, because we know friction is going to provide acceleration to m1. Now take both of them as system and the acceleration is A, which we are assuming common. Now write Newton's second law, taking m1 plus m2 as system. So the only force this side is your F, and here there is friction, right? Because this time there is coefficient of friction is mentioned. So here will be Fk. So friction minus Fk equal to mass of system into A. So F will be, friction will go that side, plus m1 plus m2 into A. Now what is friction here? Mu k into n. Now n here, remember, has to balance, if you take the whole thing as system, N has to balance M1 plus M2G. Correct or not? If I want N here, then N here has to balance only M1G. But N here has to balance M1 plus M2G. Take both as system. Then the force down is M1 plus M2G. Normal force from the table will be N. So this N has to balance the total weight. Obviously, right, if you put something on top of it, the pressing force here will be more only. So N, what is N? M1 plus M2G plus M1 plus M2 into A. Then they wanted maximum force, so this F will be max and this A will be max. And this A max is how much? This A max is mu S into G. But mu S here, remember. Now in this problem they did not mention whether this is coefficient of static or kinetic friction. This is coefficient of static or kinetic. So we will assume they are same. So this mu1 is my coefficient of friction on M1, so mu1, and this mu2 will be here. Okay, so this will be your mu1. So now if you take M1 plus M2G common, you will get here mu2 plus here you will get mu1. So that would be the maximum force that would make both the bodies move together. More than that force, the bodies will slip. Let's now try a very interesting question. Two blocks A and B. A is on top of B and B is on a smooth surface. So here the friction coefficient is 0, so no friction on this surface. But here there is a friction coefficient of 0.2. Since they did not mention static or kinetic, you can assume both. And here the force applied is, you can see, function of time. So the force increases with time. Okay, so when time is 1 second, force is 1 by 2 Newton. When time is 2 second, force is 2 by 2, which is 1 Newton. So that way the force keeps increasing gradually. So as the force gradually increases, they want us to plot acceleration time graph of both the blocks. So in the same graph, we have to plot acceleration and time graph of block A also, block B also. Now from previous questions we know that if the force is very small, both the blocks will move together. Yes or no? So let us take both of them as system. So if both blocks move together, then you can take both the blocks as system and then write Newton's law. Here there is no friction this side, so only force along x-axis is this F. That should be equal to mass of system 2 plus 4 into A. Now the force given is T by 2, remember, so this is 6A. So A is equal to T by 12. So if both blocks move together, they will have acceleration, which is given by what formula? T by 12. So this is formula is similar to y equal to mx, right? M is in this example 1 by 12, which is the slope of AT graph, isn't it? So if I plot a graph for acceleration versus time, this function means A and T are directly proportional, so graph will look like this. Okay, so that would be the acceleration of both A and B, because right now they are moving together. Now till when they can move together, because once this force becomes very large, we know what will happen. They will be slipping on the surface because the friction here will cross the maximum static friction. So to understand at what time slipping will start, let us discuss what happens to 4 kg block, because 4 kg block is not feeling this force, remember. 4 kg block is only feeling the force of friction, because when this block will feel this force F, the friction on block A this side, and reaction of that friction will act this side, right? Okay, so for 4 kg block, if you take a system and analyze what happens, then you can see for 4 kg block, on the floor here there is no friction, and here there is a friction F this side. and that friction should provide M into A for this. Now, as long as I assume both the blocks move together, the friction acting will be static. However, this static friction has a max value. So when your acceleration becomes more and more with time, right? With time, you are applying more and more force. So more and more acceleration will happen. So static friction also has to be more to maintain this equality. So as acceleration increases with time, static friction also increases. But we know it has a max value. So when this will reach its max value, your A will also reach max value. So up to that much A, the bodies will move together. After that, slipping will start. Okay. Now what is the formula for static friction maximum value? Mu into N. Now be very careful. This M was written for this block, right? Static friction on 4 kg. So this is 4 kg is block B, remember. So this is mass of B. Whereas this N is on this surface, right? The static friction is on this surface here. So we need normal here, remember. So if you look at A separately, normal here has to balance the weight of A, remember. Right? Normal here would be balancing the weight of these two, but here we don't want friction. There is no friction only here. We want friction here. So we need normal here, which has to balance only the weight of A. MAG. So MAG. So be slightly careful here. Okay, these two masses are not same because this is Newton's law written for this system. So we have to write mass of this system here. But the friction here is between A and B. So we have to use friction here, remember. So we have to use normal here, not here. Okay, let us substitute the values. Mu is given 0.2. You can assume mu is mu s also, mu k also. MA is 2, G is 10, MB is 4 into A max. So A max will be equal to, this is 2 into 0.2, 0.4 into 10, 4. So 4 by 4, which is 1. So when your A will be up to 1, the bodies will move together. Once your acceleration goes beyond 1, then slipping will start because friction will no longer be able to provide more than this maximum static friction. So then the friction which will come will be kinetic friction. Now when A will become max, let us see now this equation. A is equal to T by 12. So when A reaches 1, your T will be how many seconds if you cross multiply? 12 seconds. So up to 12 seconds here, our body will move together, and at that moment if you put T equal to 12, your acceleration will be 1. So till this point they move together, and what is the maximum acceleration they can have? 1, so that they move together, 1 meter per second square. Okay, let me write it larger. So this is 1 meter per second square. After this what will happen? Well, after this slipping will start. Now once slipping will start, friction here will be kinetic. So let us look at 4 kg block, which is your B, remember. So B is feeling only friction, remember, so it is only kinetic friction. And kinetic friction will provide mass into acceleration for block B. Okay, so now there is slipping. So now the two blocks will slip. So accelerations will not be same. So give different symbols. So AB is acceleration of B. So what is the kinetic friction? Kinetic friction is constant, mu K into L. Now mu K and mu S here we will assume same only, 0.2. And N here has to balance mg of this A block, which is 2 kg block. So MA into G. This calculation we did before also, right? So AB will come 1, right? Because same calculation before only we did. So this is this is 2 kg, this is 10, this is 4. Right? Okay. So after this, acceleration of B will be constant. There is no time here. So B will go with constant acceleration 1 meter per second square. So this is acceleration of B graph. So B will go like this, acceleration, increasing acceleration, and then become constant once slipping will start. Now what about block A? So block A is feeling one force F T by 2 and here one kinetic friction Fk, which is mu k into N, and here is balancing MAG, and this is a mu k is 0.2 into 2 into 10, so this is 4 Newton. So apply Newton's law. Now acceleration of A will be this side, right? So F minus kinetic friction is mass of A into acceleration of A. Force is T by 2 minus kinetic friction is 4, mass of A is 2 into A. So acceleration of A will be how much? T by 4 minus, you cross multiply these two. So this will be 2 2s are 4 and here 4 by 2, so 2. So this will be the acceleration. So this graph is like your y equal to mx minus c, right? So if you look carefully, the slope of this graph, if this is along y-axis, this is along x-axis, this is along y-axis, then 1 by 4 will be a slope. Now previously when they were moving together, the slope was 1 by 12. Now it is 1 by 4. So 1 by 4 is more than 1 by 12. So now slope will increase. Also intercept should be negative. So the graph will go like this. Because if you go down like this, dot dot dot, if you do, intercept should be negative, no? So this would be the graph of A. So before the slope here was 1 by 12, here the slope was 1 by 12, here the slope should become 1 by 4 as in this equation, right? So this would be the correct graph, so you can tick whichever option will have this kind of graph. Okay, let's see this question now. Block A, block B, 2 kg mass, 3 kg mass, here friction coefficient 0.1, both static and kinetic you assume, and here's coefficient of friction is 0.2. You are applying a force on B 10 Newton. We have to find acceleration of both the blocks. Now in such problem, the first thing you do is find the maximum friction that can act on both the surfaces. So first find maximum friction here. Let me call this F1 max and let me call here F2 max. So let's calculate that first. So F1 max, how much maximum friction here you can get? Mu into normal here. Now remember, normal here has to balance only the mass of MA, remember. So it will be MAG. So 0.1 friction coefficient here, 2 into 10. So this is 2 Newton. So maximum friction here possible is 2 Newton. Am I saying this much friction is acting here? No. This is the maximum value of static friction possible here. Limiting friction also it is called. Then calculate the maximum friction here. This mu into, now normal here has to balance weight of both of them, remember, right? Already we have discussed. So it will be MA plus MB into G. So normal here will be more, remember, than here. Pressing here will be more than here. So mu here is how much? 0.2. Mass of A is 2 plus 3, 5. So this is equal to 10. Now analyze. Here they have applied 10 Newton. So if you take A plus B as system together, then here you are applying 10 Newton. Here friction will try to stop it. What is the maximum value of friction? 10 Newton. So can 10 Newton be balanced by friction? Yes, because friction can go up to 10 Newton. So since friction can go up to 10 Newton, right now friction acting here right now will be exactly equal to the maximum value. So that it will try to keep the system at rest. So right now the system is at rest. Friction here will be 10 Newton. So since the system is at rest, acceleration of both the blocks A and B will be 0. So that's the answer. Now what friction should act here? Well, if you take only the lower block as system, then here 10 Newton and friction here can go up to 10 Newton. So this friction will balance it. So do you need any friction here? No. So friction here will be 0. Okay, if suddenly some friction comes here, the body will accelerate, right? But for this, if system doesn't accelerate, how can this one accelerate? So the system is at rest because I have shown this 10 Newton will be balanced by this 10 Newton by taking whole thing as system. What if we apply a force of 12 Newton? Then what will be the acceleration of the two blocks? Well, what you do is take both as system and check whether the system will be at rest or not. Here 12 Newton is acting on the system. Don't include the internal forces, okay? And here normal will balance the weight of both of them, and that will lead to friction here. Now the friction which will try to stop the system from moving is static friction, and the maximum value we have already calculated 10 Newton. So 100% this here they will be slipping. This part will slip because the force acting is more than the maximum static friction. So the friction here will be now kinetic. Now to calculate kinetic friction, we have to just write here mu k into n, and n here is this only. Ma plus mbg has to be balanced by normal here, right? Now this mu k and mu s, they have not distinguished, so you have to assume both are mu k also, mu s also. So same will be your kinetic friction. So this will be your kinetic friction, which is the maximum static friction. So now the question is whether slipping will happen here or not. Right? If slipping will happen here, they both will not move together. So how to check? Well, the best way to check that is, first you assume. Let us assume both move together. First you assume and check how much friction acts here. To move them together, there should be some static friction here. Why static? Because if they move together, there is no slipping here. Here there is slipping because the system is moving. So here there is slipping, so here there is kinetic friction. But here we don't know right now. So in such cases, you always assume both are moving together first and see what happens. Let us find the common acceleration. So total force on this side is 12, this side is 10. So net force is 12 minus 10. Mass of the system is 2 plus 3 into some common acceleration A. So A will be 2 by 5. So that much acceleration both of them will have if they move together. Now are they moving together? Check. For that you take A as system. Now this body is trying to go this way. So friction on this body will be here. Reaction of that friction will be on A this side. And it is understood only, right? A is also accelerating this side. If you assume they are moving together, then friction on A should be here only. So let us assume the friction on A is Fa. Then what will be Fa? Mass of A into A. Mass of A was 2 kg into acceleration is 2 by 5 if they move together, remember. So friction on A, the static friction on A should be 4 by 5. 4 by 5 will be 0.8 Newton. Now can that much static friction be possible? Let's check here. Yes, because the maximum static friction on first surface here can go up to 2, but you need only 0.8. Yes or no? You need 0.8 for this body to move together with this body, right? So since friction here needed is only 0.8, easily 2 Newton can provide 0.8. Therefore, the whole system will move together. So acceleration of A and B will be same, which is 2 by 5. So that would be the answer. But first you have to check, students. And friction value, if they ask, here friction will be 10 Newton kinetic. And here, because they are moving together, friction will be static. And the static friction is exactly equal to 0.8. Don't write by mistake this, okay? This is the maximum value of friction here. This much friction should act actually so that the body can have same acceleration as this one, which is 2 by 5. Okay? What if I apply a very large force, let's say 60 Newton? It's interesting to see what we will get. Okay? So now, again we will assume they both move together. but we have to check that assumption. Okay, so here 60 Newton is acting on the lower block. Here maximum friction possible is only 10 Newton. So clearly there will be slipping here. Clearly there will be slipping here, right? So now the once it slips, friction will be kinetic, and kinetic friction is the maximum value of static friction, because mu s and mu k in this problem we have assumed same. So this will be 10 Newton. So if I assume they move together, what will be the acceleration? Well, net force is 60 minus 10 divided by mass of this system is 5, right? 2 plus 3. So acceleration will be 10 meter per second square. Now who will give this acceleration to block A? Friction on block A. And if you assume they move together, friction acting should be static friction. Static friction on block A, remember. So friction on block A should provide this acceleration. Who else will provide, right? Mass of A is 2, acceleration is 10, so you get 20 Newton. So you need a static friction of 20 Newton. But here how much maximum is it possible? Only 2 Newton. So now they will be slipping here also. So once we know they will be slipping here, our whole assumption is wrong now. They will not move together. So once I came to know they are not going to move together, how do I find the acceleration? Now it's quite simple. So take B and A separately, because together they are not moving with same acceleration. So B will feel what forces? Here 60 Newton. Here slipping is going on. Slipping means kinetic friction. Kinetic friction is 10 Newton. And here also slipping is going on, right? Here also slipping, here also slipping. And once there is slipping, remember friction will be kinetic. Remember this block is trying to go this way, so friction on this will be this way. So friction here will be kinetic, and kinetic friction here will be mu k into n here. But mu k and this mu will be same because they have not distinguished between mu s and mu k. So just like kinetic friction here was maximum static friction, kinetic friction here will be your maximum static friction here, which is 2 Newton. So now the acceleration is easy, right? Total force is 60 minus 10 plus 2, 12, right? This 2 is opposing 60 divided by mass of B. Mass of B is 3 kg. So whatever answer comes, that will be your answer, right? Similarly, what about block A? Block A is feeling friction this side, right? Reaction of this friction will be here. And that friction will be kinetic because it is slipping here. Look at this surface. So the kinetic friction is 2 Newton only. So now write acceleration for, this is acceleration for block B. Only force is 2 Newton divided by mass of A. Mass of A is 2. So this is easy. 1 meter per second square. What will be this, by the way? 8, 48 by 3. 3 1s are 3, 3 6 are 80. So 16 meter per second square will be acceleration of B. 1 meter per second square will be acceleration of A. So this is how we should solve problems block on block. Now let us see a question where there is friction and tension together. Okay. So two blocks A and B, a wire is connected between the two blocks and tension on this wire is T. If there is any tension, that tension is T. Here the force applied is F. This is applied force. They have asked us to assume the limiting friction, meaning the maximum static friction is same in both the blocks. So mu s into n is same for both, which they have given F naught. The first question they are asking is, if the applied force is less than F naught, what will be tension here? Now, first, as I tell you, calculate the maximum static friction here and here. But already they have given. So you know the maximum static friction here is F naught, here is F naught. So if you take A plus B as system, together as system, then there will be a maximum static friction of F naught from the floor, right? Floor is outside the system, remember. So here one F naught maximum can act, here F naught can act. So maximum 2 F naught can act on this system. And outside you are applying F. Now if F is less than F naught, F is also less than 2 F naught. Yes or no? So system will not move, we came to know. system will not move. That we came to know. Now take A as system. Now there is force F applied here. Now what forces can act? Here one tension can act, here one friction can act. Now whether the friction is static, well it has to be static because this whole system is not moving. This is B. So whole system is not moving means A also cannot move. So friction here should be static only. Now what is the maximum value of this static friction they have given? F naught. Now the force applied here is less than maximum static friction F naught. For example, if this is 10 Newton, you are applying only 8 Newton. So friction only will balance this. So friction has to be exactly equal to 8 Newton, not 10 Newton. 10 Newton is the max value. So if friction only will balance this, do you need tension here? No. So tension has to be 0. What that means is the wire will not be tight. That is because this block has no tendency to go this side. Why? Because friction itself is balancing this force. So the block stays at rest and therefore there is no tightness in the string. Okay, anyways, if this is 8, this is 8, how can there be tension? Then suddenly the block will move. But the system is at rest. So tension here is 0. That is the answer. Now the question is slightly different. The applied force is greater than F naught, but it is less than 2F naught. Okay. Previously it was less than F naught. Here it is less than 2F naught but greater than F naught. Again, take whole thing as system first and check. Applied force is F. Maximum static friction in the backward direction is 2F naught. This is the maximum static friction on system. Which system? A plus B. Now your applied force is less than 2F naught. So system will not move now also. Now if you look at A, you are applying a force which is greater than F naught. And here friction can reach maximum how much? F naught. More than it cannot go. So you may think the body will move, but remember this wire here. And since system is at rest, this also should be at rest. So tension here must keep this system at rest. So since F is greater than F naught, T plus F naught should balance F. So T should be what this time? F minus F naught. For example, this was your maximum static friction. Let's say it was 10 Newton. And now you applied more than 10 Newton, 12 Newton. Then tension is needed how much to keep this body at rest? 2 Newton is needed. 10 plus 2 will balance 12. So this tension should be F minus F naught. Okay, so that would be your answer. Now let's say if F is greater than 2F naught. Now you know that the maximum friction here possible is F naught, here is F naught. So on this system, the maximum possible friction here is 2F naught. You are applying more than 2F naught. So 100% the system will accelerate. Now for solving this problem, we need to know the masses of the two blocks. So let us assume mass of A and B are both same, equal to M. Till now we did not need mass, but for this problem we will need mass because we need to find now acceleration. So what will be the acceleration? I will assume like before, the maximum static friction itself is the kinetic friction. So if you remember, the formula for maximum static friction is mu s into n and kinetic friction is mu k into n. In all these problems they did not distinguish between these two. So if these two are same, Fs max and Fk will be same. So once the system moves, friction here and here will be kinetic, right? And that kinetic friction we will be assuming to be F naught itself, the maximum value. So what is the acceleration? Net force this side is F minus F naught divided by mass of the system is 2m. So A is minus 2 F naught by 2m. Now to find tension here, take M as system. Here F naught, sorry, here F and here kinetic friction F naught, and here some tension which we don't know T. But together they will move, so acceleration will be same. So write Newton's second law, F minus T minus F naught equal to M into A. So now let us substitute this A here. So this will be F minus T minus F naught equals to M into F minus 2 F naught by 2M. Right? So M will cancel F minus T minus F naught will be F by 2 minus 2 to cancel F naught. If you take this minus F naught that side, it become plus F naught. So you can cancel this minus F naught, right? Because once it goes there, minus F naught plus F naught will be 0. So you are left with F minus T equal to F by 2. Bring F by 2 this side, T that side, you will get T equal to F by 2. So tension here is now F by 2. Okay. Let's see the next question. Here is a block capital M and a small block of mass small m is in contact. Now, if you leave the small m mass, it will fall down like the marker failed, right? But if you give acceleration to this block, then you can see the marker may stay at rest with respect to the block. It will not fall. You can try with your hand also. Now, after some time it will fall because your hand cannot move with constant acceleration, right? Your hand will stop after some time. But if you are able to give a constant acceleration, then this block can remain at rest. So the question is, what is the minimum acceleration required so that the block does not fall? Why minimum? Because if you move very slowly, the block will fall. Okay, you can try it. So let's see why this block is not falling down. Let's draw the free body diagram of this block, small m. So one is gravitational force mg and this capital M is pushing small m this side, normal. Now, if this block is not falling, then this surface here should have some friction, and they have given the coefficient of friction. So here there should be a static friction to keep this body at rest with respect to this block, meaning they should move together. Now for block not to fall, which block? Small m block with mass small m, for not to fall, friction should balance mg. First equation. What about normal? When normal should provide this acceleration. Now if big block has acceleration, small block should have same acceleration, then only small block and big block will move together. It will not fall, right? So who will provide acceleration to small block? The normal force from capital M, right? So normal force equal to MA, Newton's second law you apply in this direction, because small m will have some acceleration this side. Now this static friction we know has a limiting value or maximum value. So static friction should be less than equal to maximum static friction. Now this static friction should balance mg, and maximum static friction formula is mu s into n. N should be equal to what here? Ma. So m is cancelling, so a should be greater or equal to g by mu, right? Right? Mu a should be greater from this formula. Mu a should be greater equal to g. So a should be greater equal to g by mu. So if a should be greater or equal to g by mu, what is g by mu? The minimum value. Because other values are greater. So with this much minimum acceleration, if you move the blocks, then this small m will not slip. Okay. Now we can modify this question slightly by asking not the minimum acceleration but the minimum force applied so that both the blocks move together or small m does not fall. Now what will you do to find this force? Well, you will take capital M plus small m as system. This you take as system. Then the normal force between these two you will not show because it will become in tandem. So the only force here is F, and this system is moving together with some acceleration A. So write Newton's law, F equal to m plus m into A. So when will be F minimum? When this A is minimum. And the minimum value of A so that this does not fall is g by mu. So this should be the minimum force. Okay.